So for this one, we're given a continuous function. It is twice differentiable except at x equals 5, where the derivatives are undefined. Information about the first and second derivative is shown here. At what values of x in the interval 0 to 16 does f have a point of inflection? So, what did you guys get for the answer there? How many of you got A? Okay. B? C? D? Okay, we got at least one of you got all of them, I think. All right. So, what happens at a point of inflection? Concavity changes, right? And what do we look at for concavity? Second derivative, okay? So what we need to see is second derivative changing from positive to negative or negative to positive. So right here, and it does not matter that this is undefined, okay? So it's okay that that's undefined. So from positive to negative occurs right here, x equals 5, so that's one of them. And then from negative to positive happens right here at 8. And from at 12, you go from positive back to positive again. So you don't have a concavity change there. So the correct answer for this one is 5 and 8. So B is correct. So if you picked that one, you were right. Okay. Everything they give you about the first derivative, you don't even have to know. It's just there as a distractor to try to make you think something else. Okay? Alright, questions on that one? Alright, for 4, the graph of f prime, the derivative of f is shown above. Which of the following could be the graph of f? Okay, so you're given the derivative. We've got to find the graph of f. Okay, so for this one, I don't have the answers yet, so I got to think about it a little bit myself. One of them that sticks out to me here is A. A is not the answer. A is the derivative of f, right? So A would be like the second derivative because it's because here you've got positive and then negative, increasing, decreasing. Plus we know that the derivative of a parabola, which is what this looks like, is a line. Right? If we have some x squared and we take the derivative, it'll just be an x. So this would be f double prime. So this is not what they're asking for. We got to go the opposite direction. Okay. So if we kind of think of making ourselves a chart here, this is 0 from this point to this point, our derivative is negative. It's positive right here, then it's negative again, right? Which tells us f has to be decreasing, then increasing here in the middle, and then decreasing. Okay, so we got to have something that decreases, increases, and then decreases. So decreases, increases, decreases. That works. Increases, decreases, increases. That one's out because it's wrong. It increases where it should decrease. This looks good. This one decreases, increases. It doesn't decrease over here. All right. So this one is out too. C is your answer for that one. You could also look at concavity. If the derivative is negative, no. If the derivative is increasing, so like right here we're increasing, then that should tell us that we're concave up. And so concave up until this point, and then you're concave down here, so that also works. Although you can probably throw out the others just based on the other information. Okay, questions? Alright, 5. The function f is differentiable and increasing on the interval from 0 to 6. the graph of f has exactly 2 points of inflection on this interval. Which of the following could be the graph of f prime? So we know f is increasing from 0 to 6. What does that tell us about the derivative? If the graph's increasing everywhere, what's it tell us about the derivative? It is positive. So which one can we throw out? B. B is out because B is negative some here, which would mean that the function has to be decreasing. So that is out. The other information we have is that the graph of f has exactly 2 points of inflection. Okay, so this is kind of like we were looking at yesterday. Points of inflection, you got f, f prime, and f double prime. We know if we have a positive second derivative, we're concave up. If we have a negative second derivative, we're concave down. But if we have a positive second derivative, what's that tell us about the first derivative? It is increasing. And then if we have a negative second derivative, we are decreasing. So we're going to have a point of inflection anytime we go from increasing to decreasing or decreasing to increasing. So this particular one increases everywhere. So there are no points of inflection here. This one, we go from increasing to decreasing right there. And then we go from decreasing to increasing right here. So this has 2 points of inflection. That's going to be our answer. This one has too many. So we go from increasing to decreasing here. So there's a point of inflection. Decreasing to increasing here. And then you got another point of inflection over here. So that one has too many. The big thing is don't ever, for example, A is a good distracting answer because A is always increasing, like they told you here, and A has 2 points of inflection because you're concave down here, and then you go to concave up, so you get about right here is the concavity change, and then you go from concave up back to concave down. So this could be the graph of f, but it doesn't ask for f, it asks for f prime, so that is not your answer. And so whatever they're describing, they're probably not asking you for that graph. Okay. Our last one. So for this, the graph of f double prime, the second derivative of f is shown from 0 to 6. Which of the following could be the graph of f? So second derivative tells us about concavity. It does not tell us about increasing or decreasing. Okay. So we're looking at concavity here, and what we should see for our concavity at 1 and at 4, we've got our second derivative is negative up to 1, it's positive up to 4, and then it's negative up to 6. So we should see concave down, concave up, and then concave down again. So we should be, and we should be down, sorry, up to 1. This is concave down all the way over here to 3. So that one's out. This one's concave up. That one's out. This one's concave down, probably about to 1. Then we're concave up, probably to about 4, and then switches to concave down again. So that one's looking good. Right here, we're concave down. We switch to concave up. But then right here we go to down, and then back here, back to up. So that one changes too much. So C would be the correct answer for that one. All right, questions?